So welcome to the video. Today we're going to take a look at how to do an independent t-test on version 31 of SPSS. So for this example, we're going to use data from a real study conducted in the United States by a university that looked at whether male academic staff earned more than female academic staff. So in the sex column of the spreadsheet, a number 1 represents females and a number 2 represents males. And of course, in this salary column, we have how much the members of staff earned each year in US dollars. So we can use this independent t-test to see whether there's a significant difference between how much the male and female academic staff at this university earned. So the first thing I'm going to do is go over to SPSS, and then we'll go down to variable view at the bottom by clicking this tab here. And then we're going to give a name to our independent variable. So let's call this sex. And then we just need to tell SPSS what the levels of that variable are. So I'm going to go over to this values column and then click on this bit here and then on this box. And I'm going to click this plus button and I'm going to say that 1 equals female. Then I'll click the plus button again and I'll say that 2 equals male. And when this looks like this, I'll go to OK. And then I'll use this measures column to tell SPSS that we have a nominal variable, which is otherwise known as a categorical variable. So once we've done that, we can tell SPSS what the dependent variable is. So in this case, it is salary. So let's type in salary into this name column. And we're just going to tell SPSS that this variable is a scale variable, otherwise known as a continuous variable. Then if we go down to data view at the bottom here, and if we click that, we can see that we have these two variable names appearing at the top of these two columns. So then we can just copy and paste our data from this spreadsheet into SPSS. So the first thing I'm going to do is just select this top piece of data. Then I'll scroll down to the bottom of this spreadsheet and I'll find the bottom bit of data and in this right column, and I'll click on that after pressing Shift. So I'm pressing and holding Shift to select all of the data. Then I'll press Command or Control C to copy those data. So then I'll select the top left cell in SPSS, then I'll go up to Edit and then down to Paste, and that will paste those data in. And we can see that we have female and male in this column rather than the 1s and 2s that we had in the spreadsheet. And that's because in this view menu, we have value label selected. So if we deselect that, we can just see the 1s and the 2s. I'm going to keep it selected. So once we have this set up like this, we're basically ready to run the analysis. But I'll just mention first that this test has a couple of assumptions. So one is that the data are normally distributed in each of the two groups. And the other is that we have something called homogeneity or variance, which basically just means that the data are spread out to a similar extent in the two groups. So we can check the homogeneity or variance assumption when we run the test, but we need to check the normality assumption before running the test. So we can do that now. So let's go up to Analyze and then down to Descriptive Statistics, then across to Explore. Then I'm going to transfer my independent variable to the factor list box and my dependent variable to the dependent list box. I'll then go to Plots. I'll tick Histogram, I'll untick Stem and Leaf, and I'll tick Normality Plots with Tests. Then I'll go to Continue and then to OK. So the most interesting thing here is this test of normality table, and we can see that we actually have two tests of normality. I'm going to focus on the Shapiro Wilk one. We can see here that we have the females, and then if we go over to this part of the table, we can see that we have a sig value or a p-value above 0.05. So as this is above 0.05, it indicates that the data for the females are normally distributed. However, for the males, we can see that we have a value below 0.05. It's actually below 0.001, and that indicates that the data for the males are not normally distributed. So in this case, normally, I would probably switch to doing a Mann-Whitney U-test instead of an independent t-test, because it looks like we have a violation of this normality assumption. But of course, this is just a tutorial, so I'm going to continue with the independent t-test. So we're going to go up to Analyze, and then down to Compare Means and Proportions, and then we'll go across to Independent Samples t-test. Then we'll transfer our independent variable to the grouping variable box. We'll transfer our dependent variable to the test variables box. We can see that we have estimate effect sizes here. We'll leave that ticked. And we also want to tick homogeneity of variance test. So let's put a tick there. And then we'll click on this variable and then on define groups. And we can see that we already have 1 and 2 in these boxes, which are the numbers that we allocated to the two sexes. So we can just leave that as it is. Then we'll go to continue, and then we can go to OK, and that runs the test for us. So we can see that we have these descriptive statistics up here, and for the males we have a mean salary of $115,000 approximately, and for the females we have less. We have a value of approximately $101,000. So clearly the male academic staff are earning more than the females in general. And then we can use the independent t-test to determine whether that difference is significant. However, before doing that, let's just take a look at this homogeneity of variance test table, which checks the assumption of homogeneity of variance. So what we want to see here is that we have a value in the sig column above 0.05. So in this case, we have a value of 0.260. So this is above 0.05, indicating that we have met the assumption of homogeneity of variances. And that actually determines which row we look at in this table. So here I can see that it says equal variances assumed. And so as this test was non-significant, I'm going to focus on this top row. If you see that you have a value here below 0.05, you would instead focus on the values in the second row in this independent samples test table. So the first thing I'm going to look at is the value in this one-sided p column, which is 0.003. So as this is below 0.05, it indicates that there was a significant difference between how much the males earned and how much the females earned. And I'm looking at this one-sided column instead of this two-sided column on the assumption that I had a one-sided or directional hypothesis. So a directional hypothesis in this case would be something like it was hypothesized that males would earn significantly more than females. An example of a two-sided or non-directional hypothesis would be something like it was hypothesized that there would be a significant difference between males and females. So the one-sided hypothesis is more specific. So that's essentially how we interpret the results. And let's take a look now at how to create a graph to go with these results. So what I'm going to do is go up to Graphs and then down to Bar. All of these default settings are fine, so we can just go to Define. And then we can transfer our independent variable to this category access box. And we can transfer our dependent variable to this box here. But first we just need to click this, and then we can move that over. We can also click on this options here, and we can specify that we want to have error bars by clicking this here. And I'm going to leave this option here so that those error bars are going to represent 95% confidence intervals. So once this looks like this, we can go to continue and then to OK, and that generates this graph for us. If we want to edit it, we can just double click on it. That opens the chart editor. We can change the font style by clicking on any text, so that highlights it, and then you can choose a different font. So you might want to choose the one that you're using in your report. And you can also change the size of those numbers or text. You can also change the color and size of these bars. So if I just double click on those, that opens this properties menu. I can move to the left and until I get to fill and border, and then I can choose a different color. In APA style, we usually use colors on the grayscale. So if I select a gray here and then click apply, we can see that that changes the bars from blue to gray. And if we go over to bar options here, we can use this thing to make those bars a bit narrower. So if we click apply, we can see that those become narrower, and we can just click this red button here and we can see that those changes are saved automatically in this output. So let's take a look now at how to report the results of this independent t-test. So I'm going to go over to my example here, and I can see that I have started off just by saying why we did the test. So I've said that an independent samples t-test was conducted to compare the salaries of male and female academic staff. And then I've referred to the results of the normality tests. So I've said that Shapiro Wilk tests indicated that the data were normally distributed among the female staff. And then I've entered these stats here. And then I've said, but not among the male staff. And then I've entered equivalent stats here. So let's just take a look at where those statistics come from. So if we scroll back up, those statistics are coming from this table that we generated a bit earlier. So we've got this test of normality table. We can see that we've got this female row here, and we're looking at the Shapiro-Wilk section of the table. And we have this statistic column here and a value of 0.947. So this is the females. So here we have a value of 0.95, so that's the same value, just rounded to 2 decimal places. We have a degrees of freedom value of 39, that's what we have here. And we have a sig value of 0.063, and that's what we have here. And then we just have the same values again for the males, and those are just coming from these bits here. So once we've done that, we can report the results of the homogeneity test. So we've said that Levine's test indicated that the assumption of homogeneity of variance was met, and we've said that F equals 1.27. So we have this homogeneity of variance test table, and we have a value in the F column of 1.271. So I've just rounded that to 2 decimal places, and we have a p-value of 0.260, and that's what we have here. So next we're just reporting the descriptive statistics and the results of the t-test itself. So we've said that male salaries were significantly higher than female salaries, and we've got these means and standard deviations. So let's just take a quick look at where those come from. So we have this group statistics table here, and we can see that the males had a mean salary of 115,090.42 if we round that to 2 decimal places, and that's what we have here. And then we've got the standard deviation, so that's just coming from here. And then we've just got the same thing for the females. Here's the mean and here's the standard deviation, and that's what we have reported here. Next, we're getting to the results of the t-test itself. So I've said that t equals minus 2.78. So that's coming from this independent samples test table, and I'm looking at the equal variances assumed row, and I have a t-value of minus 2.782. So I've just rounded that to 2 decimal places here. And we have this degrees of freedom value of 395, and that's what we have in this DF column. And lastly, I've just said that the effect size was small, and I've reported a Cohen's d value of minus 0.47. And so that's coming from this independent samples effect sizes table. And I'm looking at this Cohen-D's row, and I'm looking at this point estimate value here, where we have a value of minus 0.47, and that's what we have here if we're just rounding that to 2 decimal places. And I've said that that was small based on these criteria here, where 0 to 0.2 represents very small, 0.2 to 0.5 represents small, 0.5 to 0.8 represents medium, and anything above 0.8 represents a large effect. So this value of 0.47 falls between 0.2 and 0.5, and that's why I'm describing this effect as small. So that's essentially it for the independent t-test on version 31 of SPSS. I hope that helped. If you have any questions, just let me know in the comments and I will try to get back to you. Thank you very much for watching, and I'll see you next time.